Hello everyone, our team will give you a presentation that probably will change your mind on usage of AI entirely, as we hope that it can do amazing things to improve human life by making air cleaner and urban landscaping prettier. So first of all, let me introduce our team members and what they're going to tell you about. My name is Tatiana, and I will show you how we use the new value creation principle in our case. Next will be Georgi, and he will talk about why we need AI and some other high-level details of project. Artyom will tell you about our data which we use. Hondamir will tell you about our AI implementation and how it's done. Sabina will show you how we used our prototype, and Shahzoda will conclude our presentation by summary. As you can see, here we have some problems with air quality. It happened due to quite frequent tree cutting acts. A large amount of exhaust gases produced by auto transport and dust caused by soil erosion. So in order to reduce the overall air pollution index and improve urban aesthetics, our team decided to use AI to analyze the city areas and draw conclusions about whether it would be optimal and appropriate to plant trees in certain places.
Thank you. Hello, everyone. My name is Georgi, and I will tell you why artificial intelligence. You can ask yourself why you need artificial intelligence assistance at all. So the planning environment is not easy as it seems. We need a lot of human labor for estimation itself. The responsible person must go around this area and see how many trees are there. Then count them manually and make a report, spending time on traversing and counting. This can take about a week. Artificial intelligence can simplify this by analyzing the satellite images using computer vision, spending from 15 to 30 minutes. Also, it's nearly impossible to estimate population activity by other methods than using mobile phones and data that they generate. Let's talk about how our system will operate in more acceptable manner. Let's look at the graph with the system's workflow. As you can see, we just insert data in our knowledge discovery model. It will help us to make better decisions. Is it acceptable to cut trees in region Z, or we should plant trees in region X? Here you can see two more friendly examples. So in the first picture, it would be optimal to plant trees in this region. If you want to cut trees, it's better to not to do that. In the second one, as we can see, there are enough trees here. So planting is not optimal, better plant in another region.
Here you can see our knowledge discovery model and of what AI elements and data elements does consist. Our presentation will be continued by Artyom, and he will talk about data and how we use it.
Well, hello everyone, my name is Artyom, and I will describe how we gain our dataset. Our dataset would be manually prepared for the first trials, as we have satellite image with terrain. We will pick standard size for each image, like 520 12 pixel, and we standardize the size for each image and create the classification mask to map whether building, trees, roads, image and the mask both have same resolution and PNG extension. For mobile data, we will need record for phone calls, SMS, and internet communication of entire city. And this would be set in the table in CSV format. We will use Python to cut off all unnecessary information, and left only information about cell's ID. So we make summarize for every cell on number of cells through cell at any given time. IoT data is going to be compiled as air quality report from sensors. All measurements would be saved as CSV tables.
So as we get our data, we try to work on it. In this example, I will tell you about semantic segmentation. It's the process when we divide the map into certain regions. We detect on the map buildings, roads, and trees, and we try to find the ratio of them. Is there the region which contains a lot of infrastructure but no trees, or vice versa? There are a lot of trees and everything is okay. So we need the computer vision, advanced computer vision model for that. It's it's inspired by the UNet. So as you know, UNet has two components, decoder and encoder, to precisely cut out the map into the segments. And the second part of our AI model is dense decision-making module. So it will get the data from the semantic segmentation. It will get the data about population activity, which will be sorted out. And it will sum everything up and give you some insight on, do you need the trees in this region or not? So it's called tree index. So our presentation will be continued by Sabina. She'll tell you about our success with one of these building blocks.
Time to see something which is not theoretical or conceptual. Let's see the real results of our network on predicting buildings on the satellite images. Here you can see the input actual label and predicted label. As you can see, our model performs pretty well. It looks so much time to fight errors and failures during trainings. As we had problems with our dataset, we had to clean it from bad samples to avoid overfitting. At first trials, we encountered situation with poor hyperparameters, but we managed to somehow get good results by tuning our model. Here are logs of first and last epochs. Next, Shalzodo will talk about it.
As you can see, the project is not quite finished yet, but we already have some nice results. We hope that I can help to make our plant cleaner and provide us with our basic need is fresh air. To sum up, we already have our algorithm which detects buildings. What we need to do is to enhance it to detect trees and roads. We have to find a way to access CDR data to properly analyze population activity and bind it to the model. Also, IoT is not implemented yet to calibrate our predictions. In future, with full implementation and potential enhancements, projects may become something that will influence more elements of urban life and design cities for the better living and looking ones. Thank you very much for your attention.
Thank you, everybody. Hope you enjoyed this.